Unit 1, Learning Target Number 7. Recognize equivalent expressions. Let's start off with talking about what exactly equivalent expressions are. Equivalent expressions are just two expressions that are equal. So, for example, here on the left side of our scale we have 2 plus 3. On the right side of our scale we have 3 plus 2. Are these expressions equivalent? Well, 3 plus 2 is equal to 5, and 2 plus 3 is also equal to 5. So yes, both of these are equal because they have the same value. How about this one? 2 plus 3 is equal to 5, and 4 plus 1 is also equal to 5. So are these expressions equal? Yes, they are. Finally, let's throw in a variable. X plus 2. Is x plus 2 equal to 2 plus x? If you remember, this looks like a very specific property that we used in the past. This is also another example of that property. That property was the commutative property. And if you remember, the commutative property said that it didn't matter which order we put the numbers in an addition problem, that we would get the same answer. So we could have traded out the 2 and the x to get 2 plus x, and these two would be the same, they would be equivalent by the commutative property. The commutative property. These numbers can commute back and forth and we get the same value. So all of these are equivalent expressions. Let's see if we can come up with an equivalent expression for these two examples. Looking at number 1, we have the problem 2 times 3 in parentheses times 4. If you look at this, this should remind you of a property that we looked at in our last learning target. And that property was called, do you remember? It was called the associative property. Remember, what it said was that it didn't matter how we grouped the numbers in our expression. If it was addition or multiplication, we could group them however we want and still get the same answer. So, if we wrote this problem like this, 2 times 3 times 4, and we grouped the numbers like this, that this would be an equivalent expression. We can test it out. We can say 2 times 3 is 6, times 4 is equal to 24. And over here we can say 3 times 4 is 12, times 2, and that is also 24. These expressions are equivalent. Well, how about this one? Number 2 says 3 times x plus 2. This should also remind you of a property that we dealt with very recently. Do you remember what that property was? It was the distributive property. And remember, if we want to use the distributive property, we're going to distribute our 3, or our number outside the parentheses, to both of the numbers inside the parentheses. And that would give us 3 times x plus 6, or 3x plus 6. 3x plus 6 as an equivalent expression to 3 times x plus 2. Let's take a look at two more examples. Here on our scale we have a plus a plus a, and it says it's equal to 3a. Now your job is to find out whether or not it really is. Is a plus a plus a equal to 3a? If you remember anything about multiplication, yes, it is, because multiplication is just repeated addition. When we add things over and over and over again, we're really just multiplying. So here we have a 3 times, which is the same as 3a. If we had a 4 times, what would that be? That would be 4a. So it's important to remember multiplication is just repeated addition. Well, what about this side over here? Here we have a times a times a. Would that be 3a? No, it wouldn't. It can't be, because multiplication is not repeated multiplication. It's repeated addition. This is going to be a to the third. So a to the third power. You have a times a, which is a to the third power, and that is an exponent. So exponents are repeated multiplication, but multiplication is repeated addition. Let's take a look at a few more examples. Here we want to find an equivalent expression for each one of these. I've given you multiple choice on the first one because this one can be kind of nasty. we're going to work our way backwards using the distributive property. Now, we want to find which one of these will distribute to give us this one over here. So we want to take 4 and distribute it to the 4 and to the b. So we get 16a plus 4b. Does that match over here? No, it doesn't. So we can draw a line through that one. How about number b, or letter b? 3 times 5a plus 3b. Well, 3 times 5a is 15a, and 3 times 3b is 9b once we've distributed to both of them. So we know that this one is correct. And just to be sure, let's check the last one. We'll distribute the 9 to the a and the 9 to the b. We get 9a plus 9b. Well, that part is right, but this part is wrong. So C cannot be our answer either. Our answer is B. 3 times 5a plus 3b. Now, in number 2, we're just going to use the distributive property as we used it backwards last time, so we're going to use it forwards this time. 6 times 3 is 18, minus, bring our minus sign right over here, and 6 times c is 6c. So this is an equivalent expression, 18 minus 6c, for this one. 3, we have 3y plus 3y plus 3y. Now, if I have 3 y's, and then I have 3 more y's, and then I have a third set of 3 y's, how many y's do I have? Well, I have 3, 6, 9. I have a total of 9 y's. So my answer as an equivalent expression is 9y. Lastly, here we have 2 times 5 plus 6. This looks a little bit like this one. In fact, it is exactly like it. In this case, we didn't leave the multiplication sign there. We just took it out. So this is exactly the same, and we're going to use the distributive property. We'll distribute our 2 to the 5 and distribute our 2 to the 6. 2 times 5 is 10. We'll bring our addition sign over right here. 10 plus, and then we'll distribute our 2 to the 6, and that will give us 12. So 10 plus 12 is an equivalent expression for number 4.